Okay, so now we're going to do an example of using some of those common series that we showed in the last video to find a Maclaurin series representation for this one. So notice this is very similar to cosine x, except it's cosine of the square root of x. So if we look at the Maclaurin series for cosine x, for n equals 0 to infinity, well, then we know that it has this form, right? So it's going to be negative 1 to the 2n, right? Or no, this just needs to be n, not 2n. This is n. And then this is going to be x to the 2n over 2n factorial. So the only thing we're going to do is we're going to replace x with the square root of x to the 2n. Okay. So, now what happens to this then? Well, the square root of x and the square cancel each other out, so this will actually become the summation of n equals 0 to infinity of negative 1 to the nth power, and this is going to become x to the n over 2n factorial. Which then becomes what? Well, now we just put in the values here. So this is going to be equal to 1 minus x over 2 factorial, which is 2, plus x squared over 6, right? And continues in like fashion. Okay. Or no, sorry. This should be 24. Okay, but let's write this as factorial. So this would be 4 factorial. And then minus and so on. And so this series converges to cosine of the square root of x for all x in the domain of cosine of the square root of x. Which, the domain, right? So again, it's restricted by the domain of this, right? So that would mean for all x greater than or equal to 0. Okay, so this is where it's going to converge to cosine of square root of x. And that's it. Have a great day.